Hey, let's talk about patterns and sequences today. How's that sound? Write a rule for each number pattern. If you look from 60 to 48 to 36 to 24, each time you are starting at 60 and subtracting 12. Let's see if that shows up. Okay, that's what showed up. Subtract 12. So we're subtracting 12 from the previous term. Over here, 7 to 12 to 17 to 22, it's going up by 5 each time. So we could say add 5 to the previous term. So a sequence is a set of numbers that follow that pattern. Each little item in that sequence is called a term. Now, arithmetic sequences or arithmetic sequences, which is what smarter people than me usually say, that is when you are adding the same number as you go on. And even if you're subtracting as you go down the pattern, that's still an arithmetic sequence because you're adding a negative number. And then if you're multiplying a constant term, that is a geometric sequence. But we're not there yet. But that number that you're adding with an arithmetic sequence, that's called a common difference. So if you're looking at the pattern 2, 6, 10, 14, each time you're adding 4, so 4 is called common difference. So let's find some common differences. You're going from 4 down to 2, down to 0, down to negative 2. So each time you're subtracting 2, but we always have to think of it like addition. So really, we're adding negative 2. So our common difference would be that negative 2. So I want you to see if you can find a common difference with these two problems. So pause it, try it, check back in. So here I see they are adding 5, so 5 would be our common difference. Here they're subtracting 3, so negative 3 would be our common difference. All right, now let's get into actual arithmetic sequences. A runner training for a race runs 2 miles the first day, 2 and 1/4 miles the second day, 2.5 miles the third day, and so on. Find the next 3 terms of the sequence. Then write a rule to describe the sequence. Let's write the rule now. They ran 2 miles the first day, the second day they did 2 1/4, the day after that, they did 2.5, which is 2 2/4. So each time they're running an additional quarter mile. So the rule is they add a quarter mile every day. So if we were to keep that pattern going, again, 2 and like 0 quarter miles, right? That's an obnoxious way to write 2. Then you went to 2 and 1/4. Then 2.5 was 2 and 2/4. So if we were to keep this pattern going, and we'll simplify at the end, it says find the next 3 terms. So it'd be 2 and 3/4. And then it would be 2 and 4/4, which is 3 and 0/4. I'm in the way. So here's 1 term, 2 terms, and then our third term would be 3 and 1/4. So here it is if you're adding 1/4 each time. So if we just clean up those terms, 2 and 3/4, 3 and 3 and 1/4. Now, if you have a pretty good sense of fractions, you don't need to write the obnoxious way I initially wrote those problems. All right, find the next 3 terms of each sequence, then write a rule to describe the sequence. Again, it's easier to just figure out the rule first and then find the next 3 numbers. So 23 down to 19, okay, it's subtracting or adding a negative. Each time it's going down by 4. So you could say subtract 4, and the next 3 terms, 11 minus 4 is 7, 7 minus 4 is 3, and 3 minus 4 is negative 1. There we go, there's our sequence. This one's a little dicier. We have some fractions, and we have negatives, but it's becoming a smaller negative, which means it's actually becoming a greater number. So how far apart are 6 and 4 and 2/3? Well, if we add a third, we're at 5, and then we got to get to 6. So each time it's going up by 1 and 1/3. So we're adding 1 1/3 to the previous term. So -2 plus 1 1/3 would be just -2/3. And if we did -2/3 plus 1 1/3, which is 4/3, right? That would give us +2/3. And if we did 2/3 plus 1 1/3, that would be 1 3/3, which is another whole, so that would just come out to 2. So those would be our next three terms: -2/3, +2/3, and 2. Now we're going to go into a geometric sequence, which is when you're multiplying by the same number each time. So the common difference was when we're adding. When you're multiplying, it's called a common ratio. That's the number you're multiplying by as you go down the line. Now, the easy way to do that, if you look here, we have 2 to 6 to 18. It's being multiplied by 3. It might not always be super easy to see, but a way you can easily figure it out is you could just take any term and divide it by the number right before it, by the term before it. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. So that's one way you can easily find the common ratio. So here, it's going from 4 to 8 to 16 to 32. It should be a pretty easy pattern to recognize, but if you forget, you can just take 8 and divide it by the term right before it. 8 divided by 4 is 2. So we're multiplying by 2. That's our common ratio. Then it says, all right, so it's asking what's going on. Multiply by 2. Then it says, find the next three terms. So 32 times 2 is 64. 64 times 2 is 128. And 128 times 2 is 256. Cool. Let's try a couple down here. Again, you can just divide it by the previous term. 12 divided by 4 is 3. So we are multiplying by 3. If we kept that going, 108 times 3, 100 times 3 is 300. 8 times 3 is 24, so we have 324 times 3. 300 times 3 is 900. 24 times 3 is 72. Woo! And then 972 times 3, I'll just use my calculator for time's sake. 972 times 3, 2960. Oops, that's 296. Cool. All right, let's try this one. If we did 2 divided by the previous term, 4, that comes out to 1/2. So you're multiplying by 1/2, or 0.5. You could say you're dividing by 2, but again, with geometric sequences, you want to say what you're multiplying by, okay? Just like with the arithmetic ones, you want to say what you're adding, even if you're adding -3. So if we did 0.5 times 1/2, or times 0.5, that would be 0.25. If we took half of that, that would be 0.125. And if we did half of that, it would be 0.0625. Whew, that got pretty tough. Now we're going to given the option. We got to see, is it arithmetic, is it geometric, or neither? So I always like to check the arithmetic first because usually it's easiest to see, are we adding the same constant number here? 4 to 6, you're adding 2. Plus 2 is 8, plus 2 is 10. So this is an arithmetic sequence. And then find the next three terms. We're adding 2. So it would be 12, 14, and 16. Not that bad. If you look at this, 4 to 6 is up 2, and 6 to 9 is up 3. So it's not an arithmetic sequence. So what we can do is we can check if it's geometric. You just take the second term divided by the first term. 6 divided by 4 is 1.5. 9 divided by 6 is 1.5. If we did 13.5, 13.5 divided by 9 comes out to 1.5. So it's a geometric sequence. We're multiplying the previous term times 1.5. So if we did 13.5 times 1.5, we get 20.25 times 1.5, 30.375 times 1.5, 45.5625. Great. All right, so 4 to 6, we're adding 2. 6 plus 2 is 8, so it's not an arithmetic sequence. Geometric, check if you divide them. 6 divided by 4 is 1.5. 9 divided by 6 is also 1.5. But 13 divided by 9 is not 1.5. So it's not a geometric sequence. Now there might be a pattern. It says find the next 3 numbers. We could probably still do that. So here it was up 2, then it was up 3, then it was up 4. So if we kept the pattern going, it would go up 5, which would give us 18. Then it would go up 6, which would give us 24, and then it would go up 7, which would give us 31. So we were still able to figure out the pattern using our brain. It's just a little tougher. All right, we have 4 here where that is the scenario. So 3 to 9 is up 6. 9 plus 6 is not 27. So arithmetic is out. We'll check with division. 9 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27 is 3. So it's a geometric sequence. We're multiplying by 3. 81 times 3 is 243. Times 3 is 729. Times 3 is 2187. Okay. And if you got a calculator, it goes pretty easy for you. 10 to 13, you're going up 3. 13 plus 3 is not 18, though. That's going up 5, and then we're going up 7. So if we were to check geometric, 13 divided by 10 is 1.3. 18 divided by 13 is 1.38. So it's not a geometric sequence. So this is neither or neither. But we could figure out the next 3 terms, because then we would add 9. 25 plus 9 is 34. Then we would add 11, which would give us 45. And then we would add 13, which would give us 58. Cool. All right, we got 2 more of those. Negative 12 to 12, negative 12 to 12. Now, obviously, we're not adding a constant amount here, but if you take it and you multiply it by or divide it by the previous term, it comes out to negative 1. And that's true for all of them. So you can say this is a geometric sequence. We're multiplying by negative 1. 12 times negative 1 is negative 12. Times negative 1 is positive 12. Times negative 1 is negative 12. Okay. All right. Now look at this. It's going up to 200, which is going up 150, plus 150, plus 150. So this is an arithmetic sequence, and we're adding 150. So that would give us 650, 800, and 950. There we go. We practiced our arithmetic and geometric sequences.